Okay then. Well, good morning everyone. Welcome to this, the first session of the last day of TechEd. I'm Andy Wigley. I'm a tech evangelist. I work out at Microsoft in the UK. Specialise in Windows Phone. Been working with Windows Phone and Windows Mobility and mobile solutions for like forever. Some of you may know me as being one of the presenters and author of the Jumpstart video series on Channel 9, all about programming for Windows Phone 8. This session, out supporting LOB apps with SQLite and Windows Phone 8. Actually, supporting any app that's got the need for rich data, local data storage. So I'm going to take you through a new solution for working with that database that's available for Windows Phone 8 and, in fact, for Windows 8 as well. So topics, why use a database at all? I mean, I'll start with this one because a database actually isn't necessarily the appropriate solution for your local data storage. If you don't need that sophistication and just serializing to a flat file is good enough, well, that's good enough. So we'll just spend a little bit of time on that. And then once you've decided you actually need your database, why SQLite database? So I'll talk about what it is and why we're favoring it now for solutions with Windows Phone and Windows Store apps. We've got two APIs you can choose from to program with it. So I'm going to give you a little brief comparison of the two so you understand where they are. They're both valid, but they both have different ways of interacting with them as a developer. And then we'll take you through the basic CRUD operations with the SQLite WinRT wrapper, which is the one I'm going to focus on mainly in this talk. Transactions, relations, and other constraints. A little bit about the tools you can use to make it easier to work with databases on devices. Very briefly talking about having a database that you ship as content include in your ZAP, so a database that's pre-populated. And then we'll touch on the subject of data synchronization, just to wrap up with. And at the very end, of course, as with all our sessions, we have a phone to give away, so one of you in this room will walk away with this phone, a Lumia 820 device. So, Windows Phone 8, huge amount of innovation that's gone into the product, and it absolutely is the right choice for business. And when we talk about the right choice for business, particularly with the scope of this talk, it's about having a robust platform for mobile apps. So, and part of that robust platform is having sophisticated solutions for you as app developers to build out your solutions. And particularly in enterprise LOB and the kind of sophisticated apps that we're kind of focusing on here, a relational database on the client side can be a good choice. So just to check, we really need a database. So here's the scenario. One of the scenarios that a database is obviously aimed at. Now, the sharp-eyed amongst you may actually recognize this slide because I stole it from the link to SQL deck, which when that was released for what was then the code name the Mango release, a couple of years ago now. But it's obviously still true. And where you need a database is where you have got different collections of data with relations between them, hence the name, relational database. So an example here, we've got a shopping list kind of app where we've got 7 tables in here. There are foreign keys between them, relationships between records. So we've got a list item, a list record, which has got a list ID and a name, and that is a header for a number of list items, and each item in the list may have a store record associated with it. So you can see all these relationships between the different collections of data and favorites and history. So that kind of thing where you've got this kind of complex interactions between data sets is absolutely what a relational database, of course, was designed to do. Now, it may be, if you've only got simple sets of data, you can just use an XML serializer or JSON serializer, serialize your simple collection of data into a flat file, and just store that in a file. That's absolutely valid for simple data storage. But for this kind of thing, well, you cannot really easily represent relationships between one item in one collection and one or more, 0 or more items in another collection through flat files. It's kind of difficult to do. That's what the job of a database is all about. The other one that's a good choice for this is where you've got a large quantity of static reference data. And you think of a good example of that is a dictionary app where we've actually got thousands of rows in this data collection. Yeah, you could kind of try and cook up some way of serializing that to flat files, but really? How are you going to do a search for words beginning with some letter of the alphabet if it's all coming out of flat files? And you couldn't deserialize or store all of them in memory. It would blow you, and you'd be exceeding the memory ceiling that we're allowed. So the database is fantastic because you can actually you can use the database engine to read into the persistent storage and just materialize objects into memory when you need them, not have them all in memory to start with. So that's another good choice for a database. So having decided we actually want a database, why this particular database? Why SQLite? Well, start with it being the world's most popular small database. That's a good starting point. Very widely used across a lot throughout the industry. And it's public domain, it's open source. You can actually download the source for SQLite, the SQLite database engine. You can build it yourself from source code. But in our case, and with a lot of... Yeah, a question there. Yeah, sure. Isolated storage, so the question was, isolated storage has keys. Is it valid to use that? So actually you're talking about isolated storage settings has keys, yeah. So that is, isolated storage settings is just like a dictionary, a string valued dictionary, storing any objects, and there's a key into them. That's valid perhaps for a medium-sized collection of objects, but it's not designed as a high-performance data retrieval engine. So yeah, you can get some mileage for that, but again, that sort of thing, the isolated storage settings, you're not going to get that support for relationships between that and another ones. But in that case of the dictionary, yeah. Well, the thing is, well, as you'll see with the database, you can do more sophisticated searches. The thing about obviously a key value thing is you've got to know what the key is you're actually looking for. So you can't do a search on all items in the isolated storage dictionary that begin with such and such, which you cannot do, of course, do with a dictionary. So the SQLite database is, it's actually SQLite.org are responsible for it, and they have created, they already build out the database engine for a lot of different platforms. So you can download from their website ready-to-go solutions to plug into your solutions on different platforms. It's very rich features. It's a very lightweight thing. We're not talking about a database server here, so you don't have some kind of a server process running on your phone. It's actually an in-process database engine, so it gives you all the characteristics of a relational database, but it's lightweight and it just sits in, it just becomes a part of your solution. So it's embedded. The storage just is underneath, it just reads and writes to an ordinary file, so you end up with a file in isolated storage, which is the container for all that data. But inside that container, we've got, we've got tables, and we've got indexes, we've got triggers and views, so it's all the sophisticated features of a database. And it's very, very reliable. So they actually, as part of the source code, there is actually a huge suite of test code that they use to verify the operation of the database. So every time they build it out for a different platform, they run all these automated tests, these unit tests, to make sure it's functioning correctly on the platform. And they're responsible for the SQLite database engine is available for Windows Phone 8 and for Windows 8. This is their website, SQLite.org. Which is supported by a number of different players in the industry, and on there you can download the source code, and very important resource for you as a dev is the SQL syntax and also the C and C++ API reference, because as you'll see when I describe the new wrapper we've just released, it really is a very thin wrapper around that C++ API. So you can kind of read that documentation and get a flavor for the way our methods in our wrapper will behave. So, there's a few tools on there. So that's a great resource, and that's where you go, SQLite.org. Now, we already have a database on Windows Phone. I already alluded to that. I said, I stole these slides from when we released Link to SQL, which was for Mango, Windows Phone 7.1. So why do we need another database? Well, the thing about Link to SQL, Link to SQL is, underneath it is SQL Server Compact Edition. Version 3.5 plus-ish with a few, it is actually SQL C. You can copy the database out of isolated storage. You can open it in your SQL Server Management Tools 2010 version, and you can look at it, and it is a SQL Server CE database. So why are we sort of diminishing our focus on that. So the first thing to say about it is it still is totally 100% a supported solution. So if Link to SQL works for you, we're not saying, oh, you can't use that anymore. That's totally still available to you. But it's not available on Windows 8. So if you're starting to look at creating one code base and you're trying to share code between a Windows Phone app and a Windows Store app, then Link to SQL is not a choice for you. It's not available for Windows 8 Store apps. Totally supported, obviously, Link to SQL supported on Windows Phone 7.1 and Windows Phone 8. SQLite is, well, in its purest form, is only available on Windows Phone 8. There is actually a community C# SQLite, which is kind of a C# implementation of the SQLite database, which is available for Windows Phone 7.1. But it's not the true native database engine. I'll explain a little bit more about that in a minute. So SQLite is a good choice for you if you want to start building your code, one code base with a view to sharing it across our platforms. Now, if you like to work with Link to work with objects and program against your database, that is obviously what Link to SQL is all about. That is what it offers you. And that obviously is available with Link to SQL. It is also available for SQLite using one of our two wrappers, and I'll talk about those in just a moment. So there is one wrapper called SQLite.net and another one called SQLite WinRT, and I'll just talk about those in a minute. So SQLite.net has a Link way of working with it. So you're using Link statements. You don't have to work with SQL statements, which brings me on to the next row in this thing, SQL statement execution. Link to SQL does not support select star, select column, column, column from whatever statements. It's only Link to SQL, whereas with SQLite, we do absolutely support that mode of operation. And this is really where a lot of the drivers come from. We got a lot of feedback from our developer community that a lot of people love Link for working with database storage. A lot of people are not so hot on it. So it's all about giving a bit of choice to our developer community here. SQLite cross-platform, so the actual database files, you can copy them from Android or another platform, and you can open them completely on a Windows Phone app, and we can copy them around. It's completely cross-platform. The actual database format is cross-platform, even across little endian, big endian. And both supports views, both support foreign keys. Neither supports stored procedures in the way you'd understand it for a big SQL server. Triggers, though, Link to SQL doesn't have triggers. We do have triggers in SQLite, and that is actually quite a powerful capability. And this is actually the key to getting the data synchronization solution that I'm working on that I'll show you at the end. So that's a powerful thing. What about encryption? Well, actually in Link to SQL, SQL Server Compact Edition, you can supply a password as part of your connection string. And that password actually is used as an encryption key, and the whole of the database file gets encrypted. So your actual database file is encrypted. We haven't got that capability with SQLite, but I'd kind of counter that and say, okay, that's true. We can't sort of separately encrypt that database file on the phone. But if you're building an enterprise application and your devices are managed, then you can turn on BitLocker. So in fact, all of the storage then is encrypted on the phone. And of course, we've got all the normal encryption APIs in the base class libraries that you could use to encrypt data stored in specific columns. So there's a couple of different solutions there that would allow you to secure sensitive data inside a SQLite database. Right, so now we want to get this. If we've decided SQLite is the one for us, how do we install it? How do we use it in our solutions? Well, the first thing you need to do is there's an extension SDK. So you go onto Visual Studio and you go onto the Tools menu, and there's the Extensions and Updates option on the Tools menu, which allows you to install extension SDKs, and there's a bunch of them. And SQLite, as you can see there, for Windows Phone, and SQLite for Windows Runtime are two of the options you can install on there. Now, you install that extension SDK, and that actually all it does is it sticks a DLL down into your program files Microsoft SDKs, Windows Phone, version 8, extension SDKs, and underneath there is a SQLite.wp80 folder, and that's where it sticks this DLL. So that's only part of the solution. That's the first bit of it. So that gives us, that is the database engine in this DLL. So what have we got when we've installed that? Well, this is a view of our developer platform for Windows Phone. And of course, as you know, we can build XAML apps, and they can reference APIs in the blue area on the left, the .NET APIs, and of course the Windows runtime in the middle there, the red area. And of course we support native development on Windows Phone 8 as well, so that's mainly used for gaming, Direct 3D apps. And Direct 3D apps, they obviously can reference the C++ stuff here, the green stuff, standard template library, C runtime, and all this other stuff, Direct 3D. And they can also reference the Windows runtime. So the red stuff in the middle is also callable from your C++ apps. That's the beauty of the Windows runtime. It's actually callable from all of these different developer platforms at the top. So that's good. Now, when you install, and of course, XAML apps can call C++ libraries as well, so we can mix and match a little bit. So when you install the extension SDK for SQLite, what you're actually installing is a native DLL, so it sits in the green area over there. So of course, that's directly callable from your Direct 3D, from your C++ apps. So gaming and that's that they could use SQLite 3.dll just by calling the APIs on it directly, the C++ APIs that are documented on SQLite.org. That's what it is. So they can use it. But if we want to use it from our C# and VB apps, we need a runtime wrapper around it. We need we need to have a WinRT component, a WinMD around it. So that's what we do. There's actually two flavors of it. There is, so this is the SQL runtime wrapper around it, and there are two flavors of those wrappers, which is SQLite-net or SQLite WinRT. And both of them allow XAML apps written in C# or VB to call and make use of the SQLite database engine. What's the difference between those two? It's simply link or SQL. That's what it's about, link or SQL. So if you prefer link, then use SQLite.net. And you're working with link statements, so you can see an example there where it says you set up an async connection to the database, then you can say await from C in DB table customer, where some selection clause, select C. And that will call you, that would give you back a customer object. And it has an ORM, an object relational mapper, sort of built into it. So it's a nice way. I mean, I actually quite like working with link to work with databases. It feels quite natural. You don't have to worry about handling the response from a select statement and building your own in-memory objects. It takes care of all that for you. And that's the link. That's the SQLite.net style of working with SQLite. But the new one that's been released just about 3 weeks ago is SQLite WinRT. Now, this was actually shown originally by Peter Tor of the phone team at Build last year, the previous Build. So we're talking about November last year at Build. And he had a talk on using C++ in your Windows Phone applications. And he showed this SQLite WinRT, early version of this SQLite WinRT wrapper, where we're able to call the SQLite database engine using SQL statements, which is the natural way a lot of people like to work with databases. And then there's been a lot of demand from the developer community since then. Could we have that released? So a little bit late, but we finally did it. So a few weeks ago, and I was working with Peter Tor, and it's now up and available. Yeah, and as you can see there, you're working with select name, age from people. These are SQL statements. So if that's your poison, this is the one for you. You can make a choice. They're both valid. I'm not going to talk any more about SQLite.net. I did have an original version of this presentation where I did a sort of side-by-side comparison, but I would have needed a 2-hour slot to present it all. So instead, I'm going to leave you with these references to find out a little bit more. Tim Hewer was the main guy who pioneered this approach, and it's certainly a completely valid way of working with SQLite databases. The Windows Phone developer blog at the top is the important one for actually getting it installed into your solution. And then the bottom two references there from Tim Hewer and Eric Jensen are actually, they're actually talking about Windows Store apps, Windows 8 apps. But obviously the programming techniques that they're explaining in there are completely valid for Windows Phone apps as well. So that's SQLite done. I'm now going to concentrate on the new one, the SQLite WinRT wrapper. So how do you get that into your solution? So if you remember, so far we've installed the extension SDK, we've got our native DLL, SQLite 3.dll, and we need to install this wrapper. Well, we've published this up on Codeplex at sqlwinrt.codeplex.com. There is no actual download, there's no component as such, there's no WinMD. What you get is the project. So you just download the source, and you get a solution containing two projects, one of which is the source for the Windows Phone 8 component wrapper, and the other one is the source for the Windows 8 wrapper. And it's actually the same source, just shared between two projects, but it just builds out to different components appropriate for whichever you're building. So you just add that project to your solution and reference it from your managed code project, and you're good to go. Now, just one little word of warning. This wrapper, the project has a dependency on the native database engine and the headers, files, and things in there. The design. There's some stuff that comes along with the database, the DLL, such as the header files. So you can link against it in the native world. And the project that you're downloading actually references the current version of it, which has the impact that when you update that extension SDK, and periodically you'll get a prompt to say, oh, a new release of SQLite is available, and you'll download it, and it will install and update, and it updates down in your program files, Microsoft SDKs, blah, 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 SQLite, and it will give it a new version number. And at that point, this project won't load anymore. So there is, well, there will be by this afternoon, a little PowerShell script also in the download just to update those references. So if the project never doesn't load and you'll get some error about some invalid path, then you can just execute this PowerShell script and it'll update the references. You can go in and edit it. It's just an XML file, the project file. But that's just a little word of warning on that. Okay, let's show you that process. So here's Visual Studio. First of all, like I said, our tools and extensions and updates. This is where you go and install all those kind of extra bits and pieces. These are all of the ones that are available, various Bing Maps, SDK, and web developer tools. NuGet Package Manager, very important to keep that one up to date. But this one, SQLite for Windows Phone. These are all the ones I've got installed, by the way. So these are the installed ones. SQLite for Windows Runtime. So you go online, and you can see the whole long list of them. As you can see, there's masses of different packages available. So you would just go on here and you would search for SQLite, and that would return to you the available ones, of which there are a few, but those are the two that you're interested in. These are the ones that are actually published by SQLite.org, SQLite Development Team. These are the official database engines. So you install them, and that will give you, down in your program files, go down to program files x86, Microsoft SDKs. There we go, Microsoft SDKs, Windows Phone, version 8, extension SDKs, SQLite.wp80, and I see this is the version number 3.7.17, which is the current one. And when they next release an update, that will change. But in here, obviously, you get the redist, which is simply the different DLLs, the native DLLs for ARM and for x86. And you also get in here the design time stuff, which is where the header file and that kind of thing is. So that's what you get when you install that. So we've already got that in here, and then you would go to, so let's just create ourselves a new project in here. And you go to Codeplex. Let's see, we've got SQL Azure up at the moment. So you go to sqlwinrt.codeplex.com, and this is where you can get our source. You just go to the source code, and you go and pull all that. You just come and download all of that source code. I'm not going to bother continuing that, because I've already got it on here. And then you create yourself a project. Where are we? Windows Phone app. And we're going to be Windows Phone 8. And then we're going to add the native add existing project. So we go to see TechEd, SQLite. This is what you get when you download the SQLite WinRTPhone.vcx project. It's a Visual C++ project. This is the wrapper. So we add that to our solution. As you can see, it's very simple. We've got two files in it. We've got database.c++. This is the WinRT wrapper. That's it. Nothing much else. And we've got statement.c++. And I'm going to show you how to program with these. This is the wrapper. As you can see, it's very thin. There's not a huge amount of magic going on in there. It's just really a thin wrapper around the native methods on the actual the native DLL. So there you go. That's it. Now, and then you just have to add a reference from your managed project to the wrapper. And you build, and that should be good. And then we can actually start adding some bit of logic. So let's go off into app.xaml.cs, and you would start off by doing something like application launching. Let's create a method called load database, and we can generate that. And then we can put some code into here, so we can do something like var db equals a new SQLite WinRTPhone database, and then we're going to actually give it a we need to put there's two forms of the constructor. You can just give it a storage file if there's one already there, or you can give it a folder and a name. So I'm going to use that one, which is application data. I just need to fix up that reference using windows.storage, application data.current dot local folder. That's the actual local storage, isolated storage as you'll know it. And then we give it a name, SQLite db.db. Why not? It doesn't matter. There's no kind of convention on that. So here we new up the object, and then we actually open it. So we call await db.openAsync. Oh, it's an async method. Await. Let's try that again. Get the IntelliSense working. .openAsync. So there we open a connection to the database, and then you can start throwing SQL statements at it. So we can say string SQL equals, and we make a string, and then we say create. It doesn't have to be uppercase. It just seems to be convention with this thing. Create table if not exists, which is a very handy thing. So it won't fail if you don't need, if it actually already exists. And then if you want to do multi-line, not a lot of people know this, you can just put ampersand on there, and now we can make it nicely formatted as well. So we can create table if not exists, and we call our table customer. And then we can start putting some columns into it. ID is, let's say, integer column, and then we'll say it's a primary key. Now, of course, what you would do is put all this kind of thing into string resources or something like that. You wouldn't necessarily type it out, but this is just to show you the principle of it. And then we can make another column in here, and then let's say that's name, and we could make that a varchar, varchat, varchar 140. And actually that's probably good enough just to prove the principle of the thing. So that's my statement, and then we can execute it. So we await db dot execute statement async is one of the ways you can execute a statement, and then we give it the string, which is SQL. And what's that? Oh, I'm missing a bracket. Thank you so much. There we go. Okay, and then we can build it and run it on our emulator, and well, it doesn't crash. Not actually done anything with this yet, but you know, you get the principle. We actually have got now, believe it or not, a database. So we've got a database that's been created with that table in it, and in the next demo, obviously, we'll put a little bit of flesh on the bones and do something a bit more interesting. But that gives you a flavour for what it's like to work with it. Right, so now the basics. You saw a little bit of the basics there, but then let's just talk about all the different ways you work with it. So, yeah, first of all, just to stress, I've already said this a couple of times. What we've got here with this new wrapper, it really is very much a thin wrapper around the C++ API. So you're working with SQL statements, you're using methods, well, you're using methods that are like the C++ API, but this is definitely a modern API. So they are async, it's all async, and it throws exceptions if something goes wrong. So this is the modern API style. But underneath it, it's a modern API wrapping an old school, if you like, C++ API. So you're working with all the SQL statements that are all documented on SQLite.org, but you're working with SQL statements and parameterized queries and statements. So this is well, we saw a little bit of that. This is what I just showed you. This is how you create a database and tables. But I want to call out particularly the exception handling. So it is an async, like I said, it's a modern API. So if something goes wrong, it will throw an exception. And being a SQL WinRT component, it will actually be manifested as a COM exception. It's not particularly friendly, and we all thought it's in the back of COM, but it's back, and it is manifest in these SQL WinRT, WinMD components. So you can catch a COM exception. Now, trouble with COM exceptions is you get a horrible H result and a magic number, and it doesn't actually communicate very much to you as a developer. So we've got, in the API, we've got a very helpful method called getSQLiteErrorCode. So you call that method passing that H result, and it will give you back the SQLite code. So those are all documented on SQLite.org. Show you that. Go over to SQLite. Let's go over here. SQLite.org. And you go into let's go into the C language APIs, and you can kind of drill down. That's the functions. Well, let's go and have a look at one of the statements in here. Let's like SQLite 3 prepare, and this actually is compiling a statement, and it will give you back an error code. So there's a list of the SQLite error codes. So it's in there. These are the kind of codes you'll get back, and it gives you a description of what they all mean. So you can get that code. So that gives you a bit more information that's a bit more meaningful than those horrible H results. Now then, when you want to insert an object into a table you've created, there's two forms of this, actually. We work with parameterized queries and parameterized statements. So where you've got variable stuff that's going into a statement, you will actually prepare the statement using prepare statement, where you have the SQL, insert into customer, and then the columns, name, city, contact, values. You can use @name, @city, @contact, or in a couple of slides I'll show the other one, you can just put a question mark, and those are like anonymous parameters. But this way you're actually giving them a name, they're named parameters. So then you need to actually plug in the real values into that statement. So you've prepared it, and then you call these methods bind text parameter, or bind int parameter, or bind int 64 parameter. There's different flavors of that with name, and then you just specify the name and plug in the value. Then the way you execute a statement, well, I showed you one. If you haven't got variable stuff or you're not returning any rows, there was that one I showed you for creating tables, which was execute statement async. The other way is called, if you've got a kind of a statement that might return, this actually won't return anything. You could probably do the other one, but you call step, and this is the SQLite 3 way of executing a statement. It's called step. That's what it does. That's what we do, step async. So that's an insert. So to select something from the database, you do something similar. Prepare statement async, select statement, select ID, name, city, contact from customer, where ID equals some variable value. So, and then we call step again. And that will return true if it actually returns an object, if there's a row. So basically, if you've got, we're expecting a single result from this, But if you're getting a collection of rows back, you simply have a while read statement.step async equals true. So it will keep looping round, and it will return true as long as there are more results to give you. So it will give you false when you say no, you've had all your results. And then you need to do something with the results. So customer view model it's just a custom object in my solution, which is the in-memory representation of an object that's stored in the database. So this is where one of these link things actually gives you a bit of value, because you don't have to do this low-level plumbing code. But I'll show you in the demo, I'll show you in a minute how you can kind of hide a lot of this complexity and organize things quite nicely. But yeah, you need to sort of new up an in-memory version of that object in the database, and that's what we're doing here. So we've got a row set has been returned from the database engine. We then need to extract the values from that row set. So you can use this get int at, get text at, get int64 at. There's different flavors of it for the different types. And you give and then it's the column position, 0, 1, 2, and 3. So this is the way that the C++ API works. So you get the values out and plug them into your in-memory object. The other way of doing it is you can actually, instead of doing it by column index, you can actually do it by the column name, which is probably a better way of doing it. So we have this enable columns property method you can call, and then when you get your results back, you get the results are returned to you not as this kind of numeric collection, but actually as a dictionary. A string valued dictionary of values, and you simply key into that dictionary. So this is probably a bit less error prone, but as Peter Tor himself said, that's Peter Tor's comment, it isn't super useful as all columns are actually returned as text, so you don't actually get the right type back, so you have to parse it then, or parse the text in order to convert it back to an int or an int64 or whatever. But that's probably a less error prone way of coding your selects. So update. I said a few slides ago, we have this two-way of doing parameterized queries. You can do named parameters or you can do anonymous parameters. And this is an example of anonymous parameters where you just got question mark in there. Set name equals question mark, city equals question mark, contact equals question mark, where ID equals question mark. And then you have to plug again the values in. Bind, this time, before we had the bind text using name, bind text with name, and then this is the other one, bind text parameter at. And you give it an index. Notice, though, that the first item, the first anonymous object in that statement is not 0, as we might expect, but 1. Now, I did think when we were writing this wrapper, maybe we should make this 0, because, who has 1-based collections anymore? VB6, I think, was the last time we ever had 1-based collections, but we're not used to that in the .NET world. But since we are a thin wrapper around the C++ API, and this is what it does, we've stuck with this. But you're downloading the source code for the wrapper, so if you really hate this and it offends your sensibilities, you can change it. But it is what it is, so we left it at 1. Finally, delete. Delete statement, delete from customer where ID equals some value, and this is, again, we're not returning any rows from this, so we can just call execute statement async. So that's nice and simple. We've seen the CRUD operations there: create, read, update, and delete. So now, a demo, a more meaningful demo than the previous one. Now, this demo is a proper solution. This is not your standard demo where we just have brain dead simple little examples. What this is actually is an example of a good way of working with a SQLite database using this wrapper. So I'm going to dig into a few aspects of it, but we're not going to have time. We could spend a lot of time digging into it, but I want you to get the flavor of it, and I'll walk through how it works. But the whole of this sample is on my blog. So if you go to andywigley.com, you can download this sample and spend some time looking at it. And like I said, this has come, and Peter Tor did a lot of work on this sample as well. So this is meant to be an example of best practice for working with a SQLite database. It's proper code, if you like. So we will run this thing up. And it's a database where we're starting this up. No, that didn't work. Okay. we've got to just change. I was running this on device before. So let's see, I need to go to the configuration manager and change that to x86 because we're running on the emulator, and that should be good this time. That's one of the things you get when you're working with native stuff. Okay, so we're in application launching, and we're going to step into load database, which is a more sophisticated version of what we saw before. Step into that. We get a reference to it. It's called SQLite demo.db for this app. We open a connection. We're creating a customer table with 4 columns in it. And it's an auto-increment primary key, and then we execute it. There we go. And then we're creating a project table as well, which has got a foreign key referencing back to the customer. We'll talk a little bit more about foreign keys in a while. So we've got 2 tables in this, project table, there we go, and we're enabling foreign key constraints. I shall talk about that some more just shortly. And then, this is kind of interesting. What's this? dbloaded.set. Well, dbloaded is an old-fashioned semaphore, a manual reset event. And what this is here for is this is kind of one of the hidden perils of using async and await in your startup logic, is that it is efficient. And the hidden peril aspect of that is that because it kind of spins long-running stuff off into the background, you can very easily get to the situation where your application launching logic is still executing, hasn't done yet, and your main page.xaml is already into its on navigated to and expecting to sort of, well, read data from a database in this case, which hasn't been set up yet. So you need to have some kind of synchronization to make sure that your logic later in your app that's dependent on something completing in your launching logic, you need to have a gatekeeper, if you like, to make sure that you don't get these synchronization problems. And that's what this is doing. So dbloaded is a manual reset event that's initially set to unsignaled. And we've got this method built into our app class, a static method, which is an async method called getDatabaseAsync. Actually, I probably could have renamed that as getAccessToDatabaseAsync or something. So what this is my gatekeeper method. And what it does inside here is it waits on that manual reset event. So if that reset event is still unsignaled, this will just block. But it's in a task, so it's on, it's spun off into the background. So it's not blocking in the sense of freezing your UI thread. It's doing that efficiently. But it will block until that manual reset event is actually set. And we call this method everywhere in our app that's accessing the database. The first thing we do always is call this app.getDatabaseAsync, and you'll see this. Now, when does that get set? Well, of course, it gets set here. This is what we were just stopped on. So that manual reset event gets signaled when this application launching logic has completed. The database is set up, our tables are created, we're good to go. Right, I'm going to let this run, and we're going to end up in main page. Or maybe we don't. Okay, this is main page. Now, what I've got on main page, I've got a method called reset data, which just simply creates some objects in my database manually, just so we've got something to look at. And it inserts a load of data. So I'm going to hit that now. This is the method. First of all, we empty anything out, execute that, and execute from the project and the customer tables. We clear a view model thing, and then we're creating a list of tasks, and then we're going to create a lot of async tasks, where the first one inserts a customer, and then when that is completed, we continue with inserting a project. The reason why we do it like that is obviously we're inserting a customer. If you remember, the primary key on that is an automatically allocated ID, so we want to do the insert on the database, find out what ID it's been given, and then we're creating project records, which are children of a customer, with the correct customer ID. So that's what we're doing here. So we're then inserting some projects, and we're doing that with a customer, and inserting and obviously I'll just jump into one of these. Insert customer. Obviously, there's the SQL statement. Insert a customer. We do our binding the values in, and then we call step async, and a little bit of stuff going on. We just got a little bit of information going to the output window down here so we can see what's going on. There we go. So that's the insert, and then we also find out what row ID has been allocated to it. Select row ID from customer. So we're getting that value back, because obviously we need to then plug that into when we're inserting the project. Oh, and here we are. We've ended up in, this is the gatekeeper method. I didn't really want to talk about that just yet, but you can see that it's checking we've got access. Anyway, there we go. So now we've got 4 customers in here, and we can select an item on the list. Let's go to AdventureWorks. We now switch to a new page. This is the customer projects view page, which shows the detail from the selected customer and all its projects. And the first thing we do, the view models. So we've got view models in this solution. I'll show you them. There's the customer's view model, which has a list of, this is the in-memory representation of objects we've pulled out of the database. And I'm going to step through some of this in a minute. There's not a lot of stuff in here. This is where you don't put your SQL statements littered throughout your pages. You stick them all in this view model class. And an individual customer in memory, that's what it looks like. And it's obviously got ID, name, city, and contact properties that we're going to fill in when we read an object. And it's also got an isDirty flag, so we know when it's been modified by our code. So where were we? Which I'm going to step, and then we can see where we were. So here we are on Navigator 2, back in that page. We get our view model. Here we go. We go into customer, await customer's view model, get default. We're going to go into the database and fill in, go and read from our database. So I'm going to step into that. And this is the get default instance of our view model. It's a static object. And then actually here we call the get item async. Now this class here, you'll notice on the right here, we're actually in an object called table view model base. So this is the base class of all my view models. And this has the generic, it's a generic class. It has all the templated class that has the logic for getting all the items from a table, getting a single item from a table, inserting an item to a table, updating. So this is just generic code you will use over and over again. The actual, and you'll notice that this is the base class, but it's got all these abstract methods up here, which is where you put the table-specific logic. So this is why, this is customer's view model, like this is table view model base. So actually I'll just step through this. And we see that call to get select item SQL. That's one of these abstract methods up here. Get select item SQL. And if I step into that, we're actually now in the child class. This is customer's view model, which inherits from table view model base. So like I said, this is the pattern for good practice for building out your SQLite solutions. And we are getting the SQL needed to select an item from a customer table. And that's returned back to the caller, which is here. And then next, we call fill select item statement. That's another one of these abstract methods, which again calls out into the child class, and we simply fill in the value in there. And then we enable the columns just for kicks, as it says, and then we step async to actually execute it. And then, having pulled, we've done our select statement, we've got our values out of the database, then we need to translate it into an in-memory version of that so we can work with it in our app. So then we call, again, create item, which is another one of these abstract methods. But this one actually news up a customer view model by reading the values out of that statement. So like I said, you download the code and study this, but this is a pattern you can use. That customer view table view model base is a generic class that will mean that you just don't have to write loads of repetitive code. You just create these child classes. We've got customers view model. We've got projects view model, which does something very similar for the projects table. Again, inherits from table view model base, so you get the idea. Right, and here we are. This is the customer, and then of course we've got projects as well. So we can go and look at this is just a pivot. There's the customer details, and here's the project, so we can go into the projects. So, and you can see we can go back. Let's clear that now. And we can go, so now that's the list of projects for that, and we go back again, and we're back at the thing. So, and obviously we can edit the details of a customer. Pico, I don't know, there we go, change something, save it, and here we are, we're into save button, click, and all the logic here to actually say, is the view model dirty? Yes it is, because we've updated it, so then we call update down into our data handling to update it down in the database. I'm not going to bother stepping through all that. So you can edit stuff, and of course it's all stored in the database, because the next time I launch the app, hello, oh there, I've seen that before. We load database, and this time it will do the same thing. There's our we're executing stuff, we're doing the same stuff, but also there's our Guido Picare that we changed. It's all stored, and we've got a nice database-driven example there with a couple of tables and relations between the two. So that's a proper example of using it. Any questions? I know it's kind of a bit speedy going through that, but that's why I wanted to point you at the blog so you can study it. So, and want you to go away with some real best practice stuff. Yeah. So the question was, is that problems with async and returning on different threads? And is our semaphore enough to prevent those kind of problems? That semaphore I showed you is a fairly primitive thing, just to say, have I actually loaded my database? So your database creation logic, has it actually executed? So at the end of that, we know we've got an active connection that we are going to use throughout the rest of the logic. So it's perfectly sufficient for this. And the async methods that are on this wrapper are pure async methods, just making calls down to the database engine underneath. So I doubt that you'd have problems of the nature you're describing with this particular solution. Well, maybe we should talk about that. The testing we've done with this, we think it's a thin enough wrapper that you should avoid any problems with it, and this solution certainly has proved reliable. So we can talk a bit more about your specific issues afterwards. Yeah. Right, and what about some more sophisticated stuff? So, transactions, relations, and other constraints. Every statement that you execute against a SQLite database is always in a transaction. It's one of the things about SQLite is it is very reliable. Everything is ACID, so if it's interrupted, it won't leave the database corrupted. So, and any statement you execute, no changes can be made to the database except within a transaction, because if you don't explicitly declare a transaction, it will inherently create one around and wrap your statement in an inherent transaction. However, if you want to have a series of statements that you either want, you want to be sure that they all succeed or no changes are made to the database, then you can actually manually start a transaction yourself, execute a bunch of statements, and then at the end of it, call commit transaction, execute the statement commit transaction, and then you can have confidence that all of those changes will be applied to the database. Or you can hit rollback transaction, and they'll all be unwound, and you end up with the database exactly in the state it was when you executed the begin transaction. And also, if the database is closed unexpectedly, then that's effectively the same as a rollback transaction. So just to do a manual transaction, very simply, you just execute the begin transaction statement, and then you do your statement. There's only one statement being executed on here, but clearly where we say other statements, you'd have a bunch more as well. And then later on, you execute commit transaction. In actual fact, begin and commit is sufficient. You don't need to put the transaction. That's the long form of the command, but that's all you need to do. And everything is then wrapped in your own manual transaction. So that's nice and easy. Right, next little thing in this more sophisticated stuff, what about relationships? So you saw on those create table statements that there was some stuff in there to create a foreign key relationship. So a foreign key relationship is where obviously we've got a customer table which has got a lot of customers in it, and we've got a single project table which has got a load of projects in it. But there is a relationship between a single row in the customer table owns, if you like, 0 or more projects. So a project, in this one, we've got a one-to-many relationship. So one customer has a relationship with many projects. There are other kinds of relationships as well, many-to-many and one-to-one, obviously. But this is an example of one-to-many, which means that we need to have some kind of way of linking back from a row in the project table to its parent, the customer, in order to be able to select the matching project rows for that customer. And you do that just by having, in each project record, you store the primary key value of its parent, of the customer. You just store it in there. And that's known as a foreign key. And that's obviously how you define the table. Create table if not exists, project, ID, customer, integer. And then you say, so the customer ID that's bolded there, that's where we store the actual value of the customer record, the parent customer. So we can then later on do a select from project where customer ID equals 345 or whatever, and then it will give you back the right rows. So that's enough in order to express that relationship. But we can also have this thing on the bottom, a foreign key customer ID references customer ID. So what that is doing is saying that the customer ID column in this table actually is a foreign key reference back to the ID column in the customer table. So that's a foreign key constraint. So a constraint is something where you are building in some logical controls, some data health features into the database so that the database itself is making sure that you're not storing rubbish data in there. So that's a foreign key constraint. That's how you reference it. That's how you express a foreign key constraint in a create table statement. There is a gotcha with this, and it is that SQLite does not actually enforce foreign key constraints by default. Odd thing, you might think. Well, yes, it is. But what it is SQLite has been around for quite a long time. We're now on version 3, and the thing is that they are actually disabled by default for backwards compatibility. But obviously, if you're doing new stuff, then you want to turn that constraints on. And you need to do that with a pragma. There are a lot of pragmas, actually. You can look in the docs for the pragmas. This is the foreign keys pragma, and you just need to set that to on. I don't know if you noticed, actually, in my load database method, I was setting it on. That enforces that pragma and makes sure that enforces the foreign key constraints. And once you do that, the database engine will throw an exception if you try and store a rubbish value in that customer ID reference column in a project record. There are other constraints that you can take advantage of, again, that are in this kind of keeping the health of your data and getting the database engine to do part of your work in making sure that your the data in your database is in good shape. So obviously the one that is a kind of no-brainer is the primary key constraint. You can only have one of them per table. You can also have a unique constraint, which means that every value in that column, in that table, must be a unique value, which is kind of inferred by a primary key includes, included in includes a unique constraint as well. But you can put it on any column. Not null means that you've got to supply a value in there. And then finally, there's a check where you can actually put an expression in that's evaluated every time you do an insert or update. And that expression will have to return true or false, 0 or 1. If it returns 0, then the constraint fails, and again, you'll get an exception. So that's a bit more of a variable one. So there's a reference in the docs there you can read up on those constraints. So you can include all of those. Now here's a weird one. Actually, SQLite, we're creating a table, and we've created a table, and you put types in it, like and say, okay, this is a varchar 140, and this is a text, this is a integer column, this is a date time column. In actual fact, SQLite doesn't care. You could stick any value into any column. It doesn't actually enforce data type constraints. Now that's a bit odd, you might think. Well, yes, it is a bit odd, but actually it's a feature that it does actually, you can actually take advantage of it, and I've used it in my data synchronization solution, because it does allow you a little bit of flexibility, and you can kind of have dynamic columns, if you like, which can be nice, but it's also obviously a recipe for potential disaster in the wrong hands, so use very carefully. So when you do a create table, you're thinking, well, why am I bothering? Why don't I just call every column blob, which effectively means I don't care. But actually it does actually use that declared data type. It kind of uses it as a hint. it will use it as a hint that you actually would prefer values to be of that type, but it's not going to enforce it. If you want to put something else in there, that's up to you. But so as it says there on the slide, if you declare a column of type integer and you actually try and put a string into there, it will try and do an int.parse on that string inherently, and if it can do it, then you'll get an integer, even though you've passed it a string. If it can't, it will just stick the string in, because saying, well, I don't know, so it will just do it anyway. And that's called type affinity. So it will try and do the right thing. But if you're ever looking in a database and you see rubbish values in a column, this is why, because SQLite doesn't actually enforce these column data types, which is a little odd if you've worked with other databases, but that's the way it works. Right, another important feature that you can define in your database is indices. And obviously, if you declare a primary key column, you've automatically got an index on that column. And indexes are very, very important for good performance in a database, particularly on foreign key columns. You must always put a index on a foreign key column, because foreign key column, by definition, is inherently you're doing the thing I said before. You're saying select from project where customer ID equals 345. So it needs to be able to key into this potentially quite large table and pick out the right values. And if you've got an index on it, it can go straight there. If you haven't got an index on it, the only way it can find out the right rows is to start at row 0 and go all the way through and check all of them until it gets to the end, because it doesn't know. There's an index allows it to do efficient lookups. So very important to add indexes when they're appropriate. I'm just going to do one little short demo on just to drive home that foreign key thing. So we're actually in the let's run that. Oh, it's still running actually, so I'm just going to start it up again from here. Not interested in that anymore, so let's just move on, and then I'm going to let's select Mr. Contoso, and we go to the projects, and I'm going to add a new project, and the project name is let's call it TechEd Europe. Oh, lost focus for some reason. There we go. Give it a name, TechEd Europe 13, and then I'm going to do save, and I think I've got a breakpoint further down, so let's let that run. Here we go. Insert item async. Here's that get database async gatekeeper method, just to make sure that the database, everything's running, and we should just step over that. We're saying, yeah, we're good. And then we're going to, this is obviously in the table view model base class, and then we're going to go into prepare statement async, where we get the SQL, and then we're going to go into insert statement async, which again is in the child class. And here we are. We're going to, this is where we're filling in the values which we're going to plug into the database. Now what I'm going to do is do a quick watch on item. A quick watch, there we go, item, and I'm going to, so you can see the customer ID for that is, the correct customer ID is 2. But actually what I'm going to do is change that to 99. And make sure, there we go, that's set. So now we're plugging in a bad data, and we can then come to the point where we, there we go, we filled it. Now we're going to execute it. I'm just going to let it run, and instead we've got an exception. Can't save that item. We've got an exception come back from the database, which is a constraint violation. Good, this is what we expect. That's all very good. So that's failed. So we'll quit out of that. In fact, we'll quit out of the app, and then I'm just going to go back to my app class here, and this is where we enabled that foreign key constraint. So I'm just going to comment that out, and we'll just do the same thing again. Run it up, Mr. Contoso, go to the projects tab, add a new project, TEE 13, TechEd, go through that breakpoint, through that one, and here we are going to just do the same thing I did before, quick watch. And I'm going to make this data bad again. Come on. Edit value, didn't want to do it. Okay, 99. Close that, I'm just going to let it run. And no error, it's fine. But obviously it's not showing in the list because it's an orphan. We just created an orphan item in that database. It's got the wrong key value. So we've managed to put some rubbish data into our database. We've lost a record. And we'll have a look at that database now, because we just talk a little bit about the tools you can use for working with these databases. First of all, you can go on SQLite.org, and there is a command line tool, SQLite3.exe, where you can do everything. Or you can create tables, create databases, you can do queries and insert and update, everything you can do from SQLite, this SQLite 3 command line tool. But most of us don't like the pain of command line tools, and we actually much prefer nice GUIs, nice IDEs, and there are actually a bunch of them. So if you go on that reference at the top there, actually go on the SQLite.org into their wiki, there are a list of management tools in there. And I'm not going to recommend any one in particular, just if you do a quick search and say a recommended SQLite IDE, and you'll get probably, you get aficionados for every one of the list, so there's lots of different ones. I've been using SQLite Studio. It seems to be as good as any, or SQLite Administrator are good, so I'll give you 3 there, but that's no particular recommendation. Find the one that works for you. Some are free, and some have a fee associated with them, but just find a nice one for you. And actually, it's really, really nice to have a tool like this, particularly where you're working with SQL statements inside your app, because stuff can go wrong, and you're thinking, well, why is this not working? And actually, it's really helpful to pull the database out and open it up in one of these tools, and then you can actually do you can execute statements on the fly and try and figure out. And you can even copy the SQL string from your app in your debugger and paste it into here and try and execute it in one of these tools, and you can sometimes get a few more insights, and it's a bit easier to kind of navigate around, dig around your database and figure out what actually the problem is. So it's a very, very useful debugging tool. Now, of course, none of these tools can open a database that's sitting on an emulator or on a phone. So the first thing you need to do is copy that database from where you've been running it on the emulator on the phone, from isolated storage, and pull it onto your desktop and then open it there. So, and you can use the Isolated Storage Explorer tool, which is in the Windows Phone 8 SDK, to do that. Or again, there's another GUI for that, which makes it easy. And the one I like is this Windows Phone Power Tools, which is wptools.coplex.com. And I shall show you how you use that right now. So there we are. We'll actually go and pull that database back. So let's start up the Windows Phone Power Tools. Here we are. And we're going to connect to the emulator. Currently connected, yes, I know we are. Yep. And then it's got different options. You can install and update apps in it. You can look at what apps are installed on it. Which one is this? Just a minute. Let's check the GUID. So you can actually give them names as well. You see them by GUID. So what is the GUID of this one? This one is the one beginning 75F6, whatever. Okay, it must be that one. So, because obviously I've done this one before, so I gave it a name just for ease. So these are some of the other apps, the developer apps I've installed on it. So this is the app, and you can look in isolated storage, and you can drill down, and there's my database. So we can actually get that database. Let's do overwrite existing, and we'll pull that down into we'll pull that down into my TechEd folder. There we go. C TechEd. Oh no, well, just drop it onto the desktop. Why not? Drop it onto the desktop. So we now have SQLite demo.db will be on my desktop. show the desktop. Somewhere hidden around there. There we are, SQLite demo.db database file. So now I'm going to open up the tool. And you get a nice kind of hints and things, so that's all very nice. I'm now going to add a database. I'm going to navigate to the desktop, SQLite demo.db. There we go. We're going to OK that, and then we're going to open it, connect to it, and then we can start digging around. You can actually go and have a look at the customer table. And it's pretty useful, actually. If you want to, you can do your database design in here, and then you know that create table statement, that that complicated thing I was typing in. There it is. Just copy it from there. So it's a nice way of designing your databases using a nice tool. And obviously you can look at the data that's in it. There's the 4 records that are in the database at the moment. Here's the projects table. And there's all the columns, and you can look at the data and the indexes and triggers and that sort of thing. And there's the data. And look, there's that orphan record, the one that I created a minute ago when the constraints were turned off. So you can have a good look around, poke around your data, and it's very, very useful. And of course, as you can see, you can see some of the stuff. These are my queries. It saves you query history. So this is some of the stuff I've been doing to check things while I've been working with these databases. Very useful. All right. So very quickly working with pre-built databases. Like when you so you can actually create a SQLite database somewhere else on the server or something, include it as content in your Zap, and ship it to the target. Now, when you ship a database, it actually ends up, and when a user installs an app, it actually ends up in the top there in the install folder. But obviously, when you're actually you're creating databases on the fly, you're working with local storage, the isolated storage, local folder, down at the bottom there. So your database file can be down there along with your application settings and your other files. But if you have one that's included in the Zap, it will end up in the install folder, and those are read-only. You cannot write to them up there. If you want to write to a database you ship, you're going to have to copy it from there down into the local folder. Now, if you want to read it, if you want to have it just for read-only access, you can open it up there, but there is this pragma you need to do, which is this pragma temp store equals 2. Now, this is because when you open a read-only database, or open any database, when you're doing complicated queries against it, it will create temporary files. And those temporary files get created by default in the same location where the database is. And you can't create files in the install folder. So you have to force it, in this case, to create those temporary files in memory. So this pragma is required. Word of warning, actually in dev mode, it does allow you to create files in the install folder. This is actually a bug in the Visual Studio Windows Phone SDK, the tools. You can actually create them. So you get this unfortunate thing with read-only databases. It works great during development, and then you actually ship it up to the store, and it's only then you start getting failures from people because your read-only databases, the queries you're doing against it, don't work. Simple queries are easy, but if you're doing kind of joins and that kind of stuff, then you're going to run into trouble. Right, I'm just going to close very, very quickly, because I'm running out of time, a little bit about data synchronization, which is just actually a nice excuse to show off some other features. First of all, data sync is really hard. Two-way data sync with loads of clients and all working on the same data, and you've got a back-end database, and you want all these clients to be synchronizing and getting updates from all the changes made by other clients. This is a hard, hard problem to get right, and we've been trying various different ways of doing it over the years. There is something called the sync framework, and actually, since I gave this talk, this is one of the real nice things about my job, is we created this thing, and we've put it out there in the community, and just in the 3 weeks since we released this, a couple of MVPs and people have all been out there trying stuff and building exciting stuff. And this guy, Sébastien Pertu, who is a technical evangelist in Microsoft in France, has created a two-way sync solution around the sync framework using SQLite on the client side. So have a look at that. There's a link on there. He's blogged all about it, and there's a solution. You can have a look for that. Well, that's a more complicated thing. There is a simple sort of sync solution, which is called RDA, Remote Data Access, and this is one we have used, which is still appropriate for a lot of sync. If you've taken that a good long look at it, it doesn't need to be too complicated. And actually, for a lot of sync solutions, you can simply pull the whole table down to the client, then track changes on the client, and then at some period later on, you just sync the changes back up to the cloud. So it's nice and simple, but it comes with health warnings. There's no conflict detection. It's kind of last updater wins. So, but for a lot of sync solutions, that's enough. For me, I'm building a solution that does this. There is a version I'm going to show you that works, but it's not ready for wider distribution there. But what actually is nice about this is a good excuse to show you the power of triggers. So first of all, to do change tracking in a SQLite database on the client, you're going to need a table called something like change data, which is just metadata for sync. It stores the last sync ID and actually keeps an incrementing change ID. Then on the tables you want to track changes, you need to just add a couple of columns to it. You can actually add a column, actually to be honest, a single column with a is dirty flag would be enough, but if you want to be a bit more sophisticated, you can store the date and time that it was changed and a change ID. And then you also need a table to store the IDs, the key values of any deleted records. So we typically call that a tombstone table. So whenever you delete a record, we want to store the ID of that deleted record in this other table. So then, here we are. Here's a trigger. So triggers are great. They're a little bit of SQL that executes in the database before or after an operation. You can have both, actually. Here we're doing a trigger that executes after a delete on customer. And all we're doing is we update the change ID value stored in that change data metadata data table. And then we insert into the customer tombstone table a row which stores in it the ID of the deleted customer. And this is happening after the actual delete. So it's gone from the customer table, and we've put an entry into the tombstone table. So we're keeping a record of any deleted ones. Similarly, on an insert, whenever a new record is put into the customer table, we can also flag it as a new insert. So we're doing change tracking by simply, again, updating the change ID in the change data meta table, and then updating the inserted customer record. Similar thing on the update, as you can see there. Now, if you want to know what's changed, simple query like that will do. Select name change ID from customer, where change ID is not null, and you can actually do multiple syncs. And if you want to find out all the deleted rows, just get all the rows from the customer tombstone table. So you can then send a change set up to your backend server, and all is good. Now, I've got a little example just to show you, which I will post this on my blog. It's not up there just yet. Right, we're done with you. Go away. And I'm going to go and open the... This is the sample. I'm going to... oh, thank you. Thank you very much. Let's just clear that out so that we don't see any old data. And this is actually up on the database. I've got a web API with an OData service. The database is actually up here on Azure. It's a SQL Azure database. As you can see, I've got 4 rows in my database. And the solution here has got a web API service. That's down here. This is the web API. And we've got a phone app. And let's just run this. It starts both solutions. The web API, that will fail because it's on the wrong, it's on localhost. If you want to see my other talk I did on Wednesday to explain why that happens, that's not a problem. Trust me. Here we are. We've got no data in my database. I've got some buttons on here, one called refresh. And what this refresh is doing, here we've got a method here that's pulling the data. It's called pull data async, and the table name is customer. And we're going to begin a transaction. And we clear out the table, clear out the tombstone table, and we call enable change tracking, which simply sets up that meta table. Then we go to pull data async, which is going to go off to my data service, which is just a web API. It's pulling that JSON, and it's coming back. We've got our data back from the service, and we're simply going to store that. We're going to insert them all, and then we get to enable. We're going to go through that. There's 4 rows of them. So, and then, and another one. And then we're going to enable the change tracking, which sets all those triggers up. So we run that. We've got our stuff here. We can then go in and edit something, and save the change. We could delete a record. We're deleting it, there we go, and then we can actually have a list of our changes. It tells you it's done those queries I showed you on the slides to find out what's changed and what's deleted, and then I can push it back up to the server. So I'm going to push the changes up. We're syncing them up. We've got a status back. It's gone back up to the service, and if we go up to SQL Azure and run that query again, there you go. We see we've got the change Andy Wigley and the row has deleted. The code for this on the server side is incredibly simple. Let me just show you the, here's the customer controller. This is a web API. We've got an entity framework model. This is how you get that list of customers. That's all you need. And this is the post updates method, where we're looking for each customer in the changed customers and doing an add or update. Well, we actually remove and then add, so we make sure they're up to date. And then we actually delete them as well, and DB save changes. That's it. Simple. And on the client side, in the database, all that triggers does the change tracking without the end user developer having to really do very much work. So this is my vision, and I'm still working on this. It's a work in progress, and hopefully we'll put that up on Coplex in the very near future. Okay, I'm done with what I've got time to show you, so a little bit of extra reading for you. There's a blog post I wrote, which tells you basically a summarized view of what I've told you this morning. Then there's that Sebastian Pertu sync framework solution. A great series of posts by Nick Randolph, MVP, Australian MVP, good friend of mine. He's done a real series about both SQLite.net and SQLite WinRT, and he's also done some really amazing stuff, such as having a sync solution against Windows Azure mobile services. Like I was saying, this has all happened in the last 3 weeks. It's like amazing, all this energy that's come out of this. And then Matteo Pagani as well is talking about this new wrapper as well. So you can get different people's perspectives on all of this. All right. At this point, have you all got a card? Did you all get a card on the way in? Can you make sure you fill them in and then pass them into the center here? Because in a minute, I'm going to draw for this phone. While you're collecting those cards, I'm just going to talk through these last slides here. These are all the sessions that we have had in the Windows Phone track. Well, a couple more still to come. But obviously catch these on video. They're all on Channel 9, so you can catch these. Particularly some great ones, top-down guide for developers. There was my session on Wednesday, Windows Phone 8 Networking Survival Kit. And then build it for both, writing code and designing for Windows 8 and Windows Phone 8. Using C and C++ in Windows Phone 8 applications, kind of related to this one. And yesterday we had large-scale enterprise mobile apps, a speech, background agents, and management. And then today, thank you for coming to this session. We've got that was a very great, highly rated session from TechEd North America about SharePoint is the next session, and then a little bit about monetization at the end. So those are all the sessions. We've got some hands-on labs if you want to get a little bit hands-on. Work with this. Please come down to the booth. We still are giving away phones down there and doing presentations today. And you can also, even if you're unlucky, you don't win a phone this morning, there are still some other opportunities if you come down to the booth. Please, if you can, spend a minute just to give me some evaluation for this session. I'd love to know, if you found it valuable, and so please give me your evaluations. It only takes a minute. And that would be fantastic if you could do that. All right, are we good for the draw? All right, so now, one of you is going to be a lucky winner. So I'm not going to look here. I'm going to pick one of these. Another one. Oh, late entry. Okay. New shuffle. All right. Okay. There we go. And the winner is Juka Apola. Juka Arola? There we go. Congratulations. Please come up and collect your Lumia 820. All right. Yeah, thank you all very much for your attention. I hope you found that useful, and I hope you've enjoyed TechEd. Thank you. Thank you very much. All right. Congratulations. Yeah. Thanks.